That's, I think, the third leverage style leg press that I've built to adapt onto a power rack. This one, the weight loads into this kind of catch tray. So the top side of the foot plate, and I use some heavy lags to attach this piece of laminated timber at the back. So that's a double thickness of plywood and some real beefy lags holding this on. So the weight just kind of sits in the pan basically. I can add more onto this bar outboard if I want, but the style of weights I have, they tend to swing. You get a cadence going and it gets annoying, so they start swinging like this. So they just sit in the tray. Band resistance, which the back pad just floats freely, and it's just a 4x4 timber that I screwed onto the bottom of a back pad that I scavenged off of a piece of equipment years ago, and I threaded these pieces of hardwood dowel, inch and a quarter hardwood dowels. You could epoxy them in. I threaded them in since I have a tool to do that. For biomechanics or ergonomics, we found that having where your hips are elevated just a few inches over where your shoulders or neck are helps a bit. A lot of vertical leg presses are designed that way. Hips elevated opens up the hip geometry, right? It's more comfortable for me and you, right, Katrina?
Yeah.
So design criteria for this. This is not automatic in terms of racking, so you have to have an assistant. We just use a piece of heavy pipe. So Katrina's working and I'll man the safety supports, vice versa. So Katrina has a bizarrely deep range of motion that almost no leg press you've ever used, I think, right? Commercial ones, that they stop inches.
I think there's been one I've used.
Yeah, but most of them have a built-in, welded-in stop that's inches too shallow for you, right? So we wanted this to have as deep a range of motion as possible. You have to play with the height of the fulcrum at the rear a little bit to get the right ankle geometry and also the right degree of verticality. Is that a word we can use? If you get too vertical, you won't have, for one, you won't have the ankle flexibility at full extension, but also you're losing load significantly once you get above 45 degrees. So you got to play with your fulcrum height a little bit and your lever length there. This one, previous versions I've done have had a solid rotating axis that goes all the way across. This one, a different style. I'm going to go around to the other side of the rack. This pivots on two 1/2-inch bolts, one on either side of the rack. Here's the head of the bolt, and so I carefully measured and drilled through this member, and I have a wooden bushing here, and you can see the end of the bolt comes out the other side. So those are 1/2-inch grade 8 bolts, and there's no play and no noise in this whatsoever. I did wax these bearing surfaces with paraffin so they're not squeaky. And I would say this has the feel of a hammer strength machine, very solid, no torsional wobble, that kind of stuff. So these I'll have to check periodically and make sure those are staying snug. I did use nylon insert lock nuts so they don't work themselves loose in use. I did not use a solid axle going across for a couple of reasons. One, this is much less expensive and involved no welding, which is much faster to build it. I do have a welder, but once you're welded, you're locked into a design, and I may have wanted to change something up, but I didn't want that axle going all the way across here, specifically because I knew I was going to be building this leverage apparatus here for pull downs, lat pull downs, and this would be pivoting right through that solid axle had it been there. So that would have been an interference issue, and putting my my bolts on the outside solved that problem and made the build faster and simpler. Okay, safety concern here, and this is a big issue. I have a bunch of weight loaded onto this platform, and it's trying to create a fulcrum effect over this safety rod, right? So the leverage arm there with weight there wants to have a pivot point, so this weight wants to throw this whole rack upward. It basically wants to teeter-totter off of this point right here. Since this is a fairly lightweight rack and I don't have much weight storage on it, I got to be very concerned not to put one too many plates here and cause that whole thing to tip over on me. So that's a major concern. This rack came from the scrapyard. I didn't choose this design. I just worked with what was available, and there had to be 6 or 8 of these. They probably put out of business some gym by the mandates that are going on, of course. So I just grabbed some extra components. So this right here, the foot piece, is actually what these are, flipped upside down. And those were easy to adapt to this, and gave us because of that bend, gave us a little bit better ankle biomechanics especially at the very bottom of the movement. So yeah, it's always good if you can bolt your rack to the floor, or at least have enough weight on it that you're, especially if it's a leverage style, just be careful and load it cautiously and make sure things aren't getting out of balance. Especially you don't want to be underneath that and have the whole rack tip over on you. Another reason I wanted to load the plates into this kind of pan, basically, instead of hanging on a bar. So for one, this style of weights, they hang and they swing, and that gets annoying once you get it into motion. But also, and with that weight on there, I can't push it up, but I didn't want a pipe or any sort of loading horns on the side, because then I won't be able to push this up into its vertical storage position, because this bar would hit the frame. Right, so this is on just for while I'm using it, and mainly just a plate, like a grab bar to get up off the pad, and a place to hook my resistance bands. But even without this on here, you can use it perfectly well, and then you have no interference like you would if you had side loading horns. Plus, it was less work, so it's one less thing to either bolt or weld on. If I can just load the weights into a pan like this. And I guess I'll unload this and put it back into storage mode. Putting this into storage configuration. So I have some lags there that catch. It wants to fall forward, not rearward. So that's why I put this lag bolt there to catch that, and then I'm basically bunging it against the bolt head there. These are very strong bungees. It's really secure. There. And then this goes up as well. So takes what, 2-3 minutes, it's up out of the way. Doesn't interfere with any exercises that we do when it's up in vertical storage, and it takes just a few minutes to get it ready to do work on it. I really didn't want something that had to be dragged over and bolted on every time we wanted to use it. It needs to just stay bolted on and flip up out of the way for use. Otherwise it's just too much of an energy barrier to use it. So notice what are the physical constraints. These lever arms cannot be so long that they hit this top frame member either, and it has just an inch or two, if I recall. I just lucked out and didn't have to cut that shorter. Where you load the weight along this arm, make sure as I was mentioning, that your weight is not too far beyond your safety bar. You'll get that weird teeter-totter fulcrum effect, and you might exceed the strength of your frame rails as well if you do that. In general, the better, the closer your safety rod is to directly under the load, the better. That's the safest. So if that helps somebody reverse engineer their own leg press, I hope it helps. But not advice. It's just what I'm doing. It's at my own risk. It's at your own risk if you build something, of course. So if you have questions, feel free to ask. I will not be sending anybody schematics. I think you get the idea. You got to put in some of the legwork yourself to get, to get something like this. But it's as good as any commercial leg press we've used, I would say, biomechanically, if not load-wise. But we don't push that kind of weight anymore anyway. So.